Hello, everybody. ODAT Nerd here, aka Terrence. This is the pre-recorded video that is going to play at the start of every Devember video. So, what day is it? If you're watching this on the day that I recorded it, probably a day in December. What day? I don't know. I'm not creating 31 of these things. This is to tell you that we are working on the Devember project, which is a remote build system in Sublime Text. Now, down in the description, if I have done my job correctly, there should be a link to the playlist that has all of the videos in this series, which starts with the video that describes what the heck it is we're actually trying to build here. And this video will be a minimum of an hour long. I don't know how long it's going to go because I haven't recorded it yet. It's still November right now while I'm reading this to you out of my brain. It's not actually written down anywhere. I think that's probably easy to tell. I'm not very good at talking off the top of my head into a camera. So, what are we going to be doing tonight? Don't know. Hopefully, working on something really interesting, though. Probably should have thought that through a little bit more. In any case, we're going to go ahead and say the following. If you like these videos and you want to know when there's going to be more of them, subscribe to the channel, link in the description. If you're interested in videos that aren't live in nature, there's another channel I have that is going to be providing those. I have in the past and I will again. I'm just not right now because I'm doing this every day for December and it's taking up all my free time. Link to that is in the description. Like any videos that you find useful, comment on any videos if you have any questions, and most importantly, have a good time. So let's go ahead and give it to myself in the present, if you will, to continue on faceless because I don't have the sort of setup that allows me to stream my face while I'm working. Hello, everybody. Welcome to tonight's live stream. Let's go ahead and hop right into it. And much like the other night, fair warning, the UPS man has declared for the third day running that he's probably going to show up sometime to deliver a package to me. Yeah, it's pretty late. Pretty sure the UPS man is lying, but at any point, my cell phone may bing to tell me he's delivered the package to the wrong place, or my home phone may ring to let me know that there's someone at the front door and I need to go let him in and connect my package. Should that happen, we're going to have to pause the old live stream for a second and you can watch the reticulating splines and listen to the awesome music that I selected there, whose author is down in the description there, the Incompetech dude whose name escapes me at just the moment. Now, let's go ahead and cover what it was that I did after the stream ended last night and into today. Not a whole hell of a lot, really. A little bit of research into some things. I basically spent some time looking to make sure that a queue is the thing I want and not a deck. Because of some stuff that I had read and came to the determination that yes, I definitely want a queue. And I came up with a little bit of a design change for how I wanted to get things to work with regards to the connection manager. Because if you remember, if I scooch on down over here, or sorry, the connection, I should say, I was calling self close in the delete method or the destruct method, whatever you want to call that thing. I call it the destructor because it's called when this object is destructed, even though it's, you know, not necessarily called right at the point when you do that. But in any case, um, I wasn't sure if it's safe to do this. It seems like it is. I was unable to find any information one way or the other, so I decided to just for safety swap the way I was going about doing that, and essentially allow the connection manager to have control over the life of the connection because it's the one that creates it. And I also, as we can see, if you look here in the sidebar, all of these untracked files here, I went ahead and just created I wanted to be able to run this code with actual Python and not inside of Sublime, just to get rid of those weird little niggly issues that we were having the other day, wherein, because it's unloading the module and loading it again, but it's still transient in memory, the stuff that was there before, you can have variables left behind from a previous run, and by gar, that is a bad scene. So I went ahead and just created a net test directory and copied the network code into it, and also a copy of messages.py so that we can modify these here before we roll them back the other way. As you can see, they're not checked in yet. And instead of trying to also copy test client in there, I just boosted the log function and we can merge it back later. And I put this inside a directory to make sure that even if because this version over here is the version that is in the top level of the package, as you can see right there. Every time you save this, Sublime reloads the file and ends up running the code that's in it. And since we want to have test code in it, that's not really going to help us, right? And of course, it turns out that init.py, that's the magic file you need to put in a directory to tell Python that it's totally kosher to pull stuff from a directory. So I'm just, before we commence to doing anything, we're going to use sublimerge here, not sublime merge, sublimerge. And oh, I suppose it doesn't want it. Excuse me, I need to compare it to network.py. So on the left is the version from the plugin, and on the right is the version we're going to be using for testing. So note that I inlined log instead of importing it from there, and that import slightly changed. And turns out, regular Python doesn't have a Sublime and a Sublime plugin module, so we're not going to do anything with that. Now, what are the changes that I made here? First, this is the call to connect in the connection manager. This is what actually creates a connection. When it creates a connection, not only does it pass it the host name and port that it's supposed to connect to, but it also appends it to the connection. It also passes itself to that particular object. And similarly, there is a new method here called remove, and you may recognize this code, this part right here, as what used to be in the sockets or the connections close method. Now it's saying instead of self socket, try to shut things down. I should probably tighten those up a little. Instead of doing that, we're doing this. If the connection, we're going to call this as a remove on a connection. So when you're going to remove a connection from the connection manager's connection list, it obtains the lock. If the connection has a socket, it tries to shut it down and close it, ignoring the error, which we can always tweak up later once we know the structure of anything. And then it uses a magic network slice and a comprehension to make sure that, or to replace the list in place with a brand new list that is every connection except the one that was passed, if it happens to exist, and it's using identity so that if there's more than one connection to the same place, it removes the correct one, which we're going to verify in just a minute. And here in the connection object, of course, it's getting a manager in the init, so it has to stash it. When we do the destructor, we don't have to call self close anymore, because we're gonna fix that up in just a moment. It actually sort of works now, but kind of by accident, if you will. And the last change was there's a new method called. Oh, sorry, I skipped it around, did I? Yeah, that's right. Oh, hang on a second. I just got a text message, maybe. Nope, it's not. It's not UPS. It's YouTube telling me that I'm live. I know I'm live, YouTube. You don't have to tell me. Um, yeah, there we go. This is the part I was looking for. Now, when you try to close a connection, it just tells the manager to remove it. So that's and we also have some extra stuff in there just to make that look nicer. And otherwise, this is the other thing that I added here to test the code just before the stream started. So If I go ahead and run that, where you can see that it's creating the network thread, it creates two connections. And then if we scooch on down here, we can see that it tries to close connection 1 before it destructs the manager and the connectors and the connections. And so we can see, excuse me, that it destroys this connection before it says run complete, and then we can see it destroying the network thread and the last connection when everything completely goes away. Now, I think something that we might want here as well in the connection manager is this. When you call shutdown, it quits the thread. It should also call remove once for every connection in the connection list. Now, there's perhaps a little bit of a snafu in the design because this is trying to take the lock. We don't want to do that when we close. Well, I guess we could. We don't want to take the lock before we call remove. If we put it after the part where we've joined the thread, we can be fairly assured that it's probably connected or joined up, and there's not another thread. So, excuse me. Okay. Basically, I could just iterate over the list of connections and call remove on the connection. I could modify this remove so that if connection was none, it removes all of the connections. And that might be a way around this just in the short term. Because I think, oh, and here's something else that I actually wanted to test here as well. I'm going to remove that, and I'm going to duplicate that. So we have two connections to port 7. We don't care about those calls. We know they do something and we haven't fiddled with them. And we're going to try to close connection 1, which is going to be the second one that is created. Now I'm going to guess that maybe we don't also want to do that either. Should I actually be not calling? Oh, because I'm not actually starting the connection. I'm not calling startup and I'm not calling shutdown. That was different test code. So let's go ahead and modify that as well. That was just because that was going to start up the network thread. So yeah, we won't worry about that for just the moment. But if I run that, now we can see it's creating 3 threads. There are 3 connections. The second one is the one we told it to delete, and it's pulling that one first, and then it's destroying the other 2. Now those are going away because the connection manager went away, and the connection manager holds the list. The list goes away. Everything eventually gets cleaned up. And con 1 fell off the bottom here. The fun part about that is we get to see that stuff happening after the run complete so that we can see what the runtime is doing with things, if you will. Let me just adjust my mic here for a second. Felt like I got a little off kilter. So let's go ahead and say connection manager.startup here. And then we can connect and connect. Do that one. And then now we're going to come down here and say manager dot shutdown. We're not even going to maybe set it to none. We're just going to say run complete. See what happens. So it created the network thread, the connection manager initializing. Those are in the wrong order, if you will, because this starts the thread after it does that, but that's two threads trying to output the same thing at the same time. We're lucky they ended up on separate lines, like so. So that is neither here nor there. So it launched the network thread, it created a connection, then it created those two. The connection manager shut down, connection ending gracefully. Those three go away. Now, did I still have the call to con1.close? Yes, I did. So maybe I might put a time.sleep, 1 in here just to give it time. So I would have expected that. Oh, I think I would probably need to say con1 equals none in that case, because even though it's closed, it doesn't officially go away. Now this is just my magic debug code, causing problems. There we go. Now we can see, now that there's no more outside reference to the connection, it gets destroyed when you make the call, and then the other two go away. And it is the second one created and not the first one, so it's definitely finding the right one. So that's, we're going to say good to go for that. Now, that means the next thing we want to do is, it's definitely destroying the thing we expect it to be destroying. We need to decide, do we want there to be two of these? Because I could maybe create a remove connection, which is what this is, and then a remove all. And remove all would sort of have to duplicate this. So maybe we say def underscore close connection self connection like so. And then we grab those lines and boost them up like so and say, given a connection object, attempt to gracefully close it. And what we should actually have here is log gracefully closing. How have I been doing that in my other logs? Yeah, I've been doing it that way. Okay. Consistency is key. So, well, as a matter of fact, whoops, that's not what I meant to do. We want that to be there because we want it to say no matter what. Now we can say self dot underscore close connection, and then modify the list. And if that's the case, now this is something that, I don't know, maybe could be a method later, but we don't maybe want to worry about that right now, is to go ahead and say this. For con in self dot connections, self close connection. Oh, I'll make that the whole word. So we can see it gracefully closing the one we asked for. Then it got destroyed. And then connection manager shut down. It gracefully closed the other two. But at that point, the network connection went away and the objects went away. So let's go ahead and call that a good starting point for this. Now, the one other thing that I did think about is because the close connection here is closing the socket inside the connection, that's kind of a violation of, that object has its own socket that it created itself, and something else is closing it out from under it, which is kind of a butt move, if you will. I'm going to actually boost these. Well, I'll boost this up anyway. After this. So I think maybe what we might want to do is open connection self and host and port. And then we can do this and return new connection. And then this can be new. Well, this can actually be connection equals self dot open connection host port, like so. This still does what we want. Do the underlying work of actually opening. I'm going to turn off the sidebar for now. We don't care about that. Opening up a brand new connection to the provided host and port. Now, this should all work identical to how it did before, assuming that I renamed all of the variables, which I did not. As a matter of fact, I probably should have changed those two. So there we see. This time, though, the output turned out all nice, just to the vagaries of threading. Create network thread, the connection manager initialized and launched the thread, but that logged after the thread actually did it, because spawning a thread is faster than output can be generated or caught and sent to Sublime. Then we create 3 connections, gracefully close one of them right away, and then that object immediately gets destroyed. The connection manager shuts down, which gracefully ends the network thread, gracefully closes all of the connections. The network thread goes away, and those objects go away too. Now, the whole point of that is I'm going to say this. I'm going to say self.socket equals socket, and I'm going to pass a socket to here. And we will cut those lines and pop them into open connection like so. And now instead of connection socket is create a new socket and set it non-blocking and create it. So now when you call connect, this creates the connection and adds it to the list. The connection, my bad. We needed to do it this way. I put those in the wrong order. That was totally going to blow up. Whoop. Let's do it that way. And we have to pass sock host port. So now when you say to open a connection, we create the socket, set it to non-blocking, pass it to the connection when we create it, We don't need to actually do that. We can actually just go ahead and return it and tighten that up a little bit more. And now the connection manager is creating the socket and it's also closing the socket. And maybe we might actually want to say connection.socket is none, just to make sure that we know it went away. Because if nothing else, that's going to tell us later when we did something stupid, when there's a socket that's none. When we have all of our threading issues, because those sorts of things happen. Like this, for example. Because that, I think. Oh, if self.socket else none, let's say. There's probably a keener way to do that, but so create the network thread, initialize the connection manager, spawn up the network thread, create 3 connections, which has created sockets for all 3 of them. We gracefully close that connection to host Dart on 7, and when it gets destroyed, its socket is none. Then when that shuts down, we gracefully close the other 2, the one with 4, which proves that we closed the correct one. And it gracefully closes that one. Everything goes away. And when those objects go away, the socket is none. So this sort of, if we want the connection manager to be the thing that deletes connections, then it makes sense that we want the connection manager to be the thing that opens or creates this socket. I should say if the connection object is the one that's going to close the socket and shut it down, then it should also be the thing that created it and technically connects it. So let's just look at our little sample here for a second. We do a little bit of that. Okay. And notice my note to myself there. I don't remember if I mentioned that before, but essentially the issue is if you just pass a host name like, say, odatnerd.net, and the underlying code is going to resolve that to an IP address, and it's possible for a host name to resolve to more than one different IP in both the IP4 and or IP6 genres, if you will, or address families or whatever. I guess address family is probably the more correct term for that. And it's just going to use the first one that's returned. So if the first one that's returned happens to be IPv4, then that's what it tries to use to connect. If it happens to be IPv6, that's what it tries to use to connect. And if the server is definitely using one or the other, sometimes your client will work and sometimes it won't, and you'll bash your head against the wall trying to figure out why. So the ultimate thing there is if you're the one that chose that a particular IP address was the one to connect to, it's on you if it's broken. So let's do that, because if we're going to do this, then I think we also want this as well. So I would not worry about. Oh, looks like GitGutter is having a problem running things in the background. Okay. Blocking I/O error, huh? What the hell does that mean? Well, let me tell you, I wasn't expecting that. Why is calling connect on let's go ahead and look that up. Whoops. What was it called? Python blocking IO error. Yeah. Raised when an operation would block on an object set for a non-blocking operation. That doesn't necessarily sound like a problem. Am I supposed to mask those? Huh. Do. Okay, let's do it this way. Python connection blocking. Python connect blocking IO. Maybe you're supposed to. Let's see what this says. I defined a timeout on a blocking socket. Well, it's not a blocking socket, isn't it? I called set blocking false. Does that not make the thing do what one would expect? The timeout should occur when the connection attempt was not successful. That would mean the socket is not trying to establish connection, but it seems it still is. Oh, nobody has an answer to this one, huh? Create a socket, connect it, send receive. Well, this isn't Python, but I think yeah, that is not Python socket.connect blocking IO error. Is this not a different link for the exact same thing? I hate when that happens. The socket is not in time wait. Okay, so that's 2 hits for the same thing. Okay, so yeah, that would have been, I'm going to go ahead and assume that that is in fact the case. Try that catch, except hey. Well, for the love of Pete, what was it throwing? Blocking IO error. Oh, sorry. No. Network.py line 110. All right. And then I suppose the actual problem was I had it right to begin with, except that I used exception and not error. Right on, right on. Okay. Again, this is one of those, I know, was it using more than one there? Type error? I'm going to assume if blocking IO error is the same as E would block and whatnot, those are the return codes for when you do a socket operation and it literally would block. So when you call on a blocking socket, if you call read, read hangs until data arrives or the socket breaks somehow, like the connection is closed, in which case it returns an error, and the error or error code that it returns tells you that the connection was closed or something. If your socket is non-blocking and you call read and there's data, it returns right away. If you call on a non-blocking socket a read and there isn't any data, then that's signaled back to you by returning an error of this operation would block. So don't it's just your way of knowing that there's a difference between there are no bytes read because there weren't any available and there are no bytes read because the handle was closed. So we're going to say that's kosher. So now truly when you open a connection, it creates the socket. As a matter of fact, I might even throw that up there just to get all of those. So if there's a blocking error, that'll be ignored, but if there's any other error, it'll raise an exception and opening the connection will fail. That gets propagated back up to here, which presumably doesn't get to append and just leaves unlocking the lock. And then presumably this would return none. So when you call connect, it creates the socket, sets it to non-blocking, actually tells it to connect. And when you close the connection, it closes the socket, shuts it down, and then tells it to go away. So the connection manager is responsible for the lifespan of the socket itself. That seems like that's probably good. So I want to open this repository, and I got like a few files here. I'll stage that just because I fixed that space there, but it doesn't really mean much of anything. So that is, maybe we'll fix the project temporarily too, because I think these are going to stay here until we know the network code works, and then we can roll it in, and this can go away. Message, and now I probably should have checked this in before I started fiddling with it, but we can only do so much because I ran out of time before the stream started. So I will stage that as well. And I'm just going to pop back over here. And so that'll be wholly ignored. I assume the appropriate files are already ignored there. So now git ignore is a file that changed, but that other file isn't there. And just because it's the way I roll, let us also do that. Just to make that look a little nicer. We don't need to see an empty folder there. And we'll modify, whoops, wrong file. We'll stage that as well. And we will say shift the network code out for easier testing. Oops. Existing network code into a test folder. Make Sublime ignore it while we're working. In addition, we've also made some changes to the code as it appeared in the package proper. That makes the connection manager class wholly responsible for the management of the underlying socket in the connection object. Now, if I wasn't live streaming this, I would probably save that particular file as a stash, then not pop the stash, just apply the stash, go back, remodify all of the files to look the way they looked before I started fiddling with it, and then pop the stash and go again. But I don't think we need to spend 15 minutes fiddling Git in a live stream. I'm going to go ahead and make that go away too, just to keep things clean. So we have that part happening now. Here's what we're going to do. We've made a connection manager and started it up. I'm going to comment out all of those and make this, well, let's say 5 seconds. Ooh, 5 seconds. Incidentally, I don't know, this is a fun thing. I'm used to sleep calls being in milliseconds, so I did a time sleep of 10,000, and then it was taking a long time, and that's when I inadvertently discovered that it takes seconds. Excuse me. So now we should see that, and then after 5 seconds, it should go away. That is 100% what we want to have happen. Now we can go ahead and jump up to the network thread. And run. Okay, let's say we'll change this to entering network loop. So instead of that, now connection manager's connection list is going, which is this up here. We need the connection lock and that. Now the network thread needs access to that. So yeah, we'll copy both of these lines. And again, this is one of those things where we can try to clean things up later. So we're going to do this. Now I need to say, whoa. Maybe we'll leave that one alone and search in this one. Yeah, that's the wrong one. Hang on. 3.3. Socket.select. 1, huh? It would be a hell of a thing if I had just discovered that, oh, it's not socket, it's just the module select. Rock on! Only supported on Solaris and derivatives? No. ePOL only supported on Linux? No. POL not supported? No, no, no. This one is one of those, it just says it's a straightforward interface to the Unix select system call. Wait for an exceptional condition. See the manual page for what your system considers such an exception. That's the sort of portability thing that we don't want. This is where I say, okay, let's copy this into here just to have a reference. And we'll also jump up and import select. And let's see, straightforward. Reading, writing, exception, empty sequences are allowed, but acceptance of 3 empty sequences is platform dependent. It's known to work on Unix, but not on Windows. Yeah. Timeout as a floating point number in seconds. That's the same as the other one. Okay. The return value is a triple list of objects that are subsets of the first 3. Okay, that's... I imagine that this can throw an exception. Does it say anything about that? Polling objects, queue objects, event object. No, it doesn't, huh? Okay, well, we'll just go with that. So for our just temporary purposes so that we can refresh myself as to how this works, we need to say with self.conlock. And we're going to want to say readable is an empty list. Writable is an empty list. And exceptional is an empty list. And then with that, actually, I don't think that's how we wanted to do that. What we want is readable is equal to C for C in. Now we need to grab the connection list, so we don't want self.conlock here. We perhaps want to tweak this. I think that's probably the better way to go. Why didn't I think of that before? We want up here, too far. We're going to move that down like that. So there's going to be a connection lock, the list of connections, the thread event. And then we're going to call this with self.conlock. Okay, let's go ahead and hide that again. Self.connections and self.thread event and self. Oh, that's the only one that's needed, huh? Okay. So it's going to take things in that order so that this thing can catch them and do its own thing. I assume locks are thread safe. Otherwise, life is terrible. Right? And, oh, shoot. Let's copy both of those to here. Lock connections event. So I can say self.conlock is equal to lock self.connections is equal to connections, and self.event is equal to event. And doing this is what I had in mind when I modified the close connection. Not the close connection. Remove connection to use this so that the reference to this list stays the same and it's just updated with this so that more than one reference to it, if there's more than one reference, they all still reference the same stuff. I'll move that up there too, just because it looks nicer. So now with the connection lock, C for C in self dot connections, and we're just going to do it that way. And we're suitably going to say writable. Well, actually, yeah, we'll just do that for now. And then exceptional is an empty list. Thus, so we don't need these ones here. Okay. So with the connection lock, get from the list of connections all the ones that are considered for readability, which should just always be all of them every time, as a matter of fact. We always want to know if it's readable. This one is supposed to only check for writability if it has something that it needs to send, which is uh, something that we need to double check here. We'll see in just a moment. The list of exceptional things we're going to assume is always that. Now we're out of the lock if, well, let's say it the other way. If not readable or not, or and not writable, then we might say network thread has no connections to service, and do a time.sleep 0.25 and continue. Now we don't need any of that part anymore, and we're going to do that just so that we know. So connection, oh shoot. Man, I've been doing that quite a bit. Let's try that again. So there's the network thread deciding that it has nothing to do, and then things shut down. Okay. Because there are no connections, those lists are both empty, right? And the general case, as long as there are connections, there's always going to be at least one thing that's readable. So actually, let me modify this first. Actually add the select call, and we will say rset wset xset is equal to select dot select readable writable. We'll just go ahead and do that. We don't need to create a different one every time. With a timeout of, these are all things that can be tuned. A quarter of a second, if a second is 1,000 milliseconds, that's 250 milliseconds. I probably want closer to 0.1 on this, but you know. And then we can say, now this is gonna be an unfortunate amount of output, because either nothing selects as readable or writable, or like I said, practically everything is going to select as writable. As soon as it does, it's going to be a big pain in the butt. And as I mentioned before, the reason that the connection object has a file no thing is because that's what select calls to figure out the file handle of the thing that it should be selecting on. So that just allows us to pass in a list of connections and get a list of connections. And then we can say if rset log %e items readable, this is just a temporary thing, len rset wset. Okay, now We're going to see what happens here. And we're going to try to make it actually connect to something when there's no server listening. Like so. We don't actually care what the connection object is because that thing's going to manage it and it's going to go away anyway, right? So let's see what happens. Oh, that was anticlimactic. Now let's see what happens. Socket, module socket. Oh, whoops. That's a boo-boo on my part. I think that should be self.socket. Ooh, boy, it's all kinds of mad now. So let's see what we got. Maybe we'll only do one and the other, and then we'll see which is which. But let's okay, one item readable exception in thread 1 in bootstrap inner broken pipe. I wonder if that's actually my code or exception ignored in. Well, okay, well, we'll just go ahead and firstersons. We'll say writable is that. It definitely selects as readable for some amount of time. Okay, so that's nice. Now let us uncomment that, comment that, and change this to readable. It also immediately selects as writable. And note that it still works. It didn't have that weird error that the last one had. And I suppose this will probably work too. I have a suspicion that that broken pipe error wasn't coming from this code. It was perhaps coming from Sublime running the thing. Gracefully closing a couple of connections. Okay, well, maybe we're going to need to double check this now because I don't know which one of those came first. Detecting when a blocking socket connects. Sorry. Non-blocking socket connect states. Do. Yeah. That. You're letting me down, Googs. You're letting me down. I'm gonna do a little something here. Over on this monitor, whereas you can't see it because it's sort of a proprietary work kind of thing. If I was to look in, nope. Yeah. Boy, there's a lot of stuff in here. Well, I probably want this file. Perform socket read. Do I have a select in this code? Maybe I'm looking in the wrong thing. Grep -I select. Detach new selectors, pump clients. This basically, I'm just sort of looking at some socket code. What I know does this sort of thing just to see how I have done it in the past, but I can't show it on the stream because it is proprietary code from my place of employ. Okay. If the listen socket is in the list of selected sockets, we might have a new incoming connection. Okay. Readable, writable. So there's no actual distinct code here that knows when the client is connected. Let's chase it with thus. Client has disconnected. Okay. Oh, this is listening for incoming connections. It's not listening for outgoing connections. I'm looking in the wrong place. No wonder I can't find anything. This uses the other code. Well, that right there is an unfortunate turn of events. So let's bring this over to this window and see if man select has anything to say. The timeout structure. So let it do. Maybe I actually want to. Connection-based sockets may successfully connect only once. The socket is non-blocking and a previous connection attempt has not yet been completed. Remember that guy was asking how to know if his connection is in progress or not? The socket is non-blocking and the connection cannot be completed immediately. It is possible to select for completion by selecting the socket for writing. After select indicates writability. Okay, to determine whether it completed successfully or not. Okay, so that I think is telling us what we want to know. We're going to go to is writable. We need to be in the connection list when that is the case, or we are when we're constructed, we're just given a socket and we know that all that happened was the other side said to connect. So we're going to say self.connected equals false. Thus, and down here in is writable, self send, return not self dot connected, or there's data to send. We want to copy that and we want to find the thread and say that absolutely everything is readable if, but for writable only then. And we're not going to worry about reading any data right now. So we'll actually comment that out. Well, actually, we don't even want to do it that way anyway, right? So what we actually want to say is for con in wset, con dot send. We don't need that. So the idea here is when the network thread keeps looping forever, it gets the connection lock, tries to find all of the sockets that are readable, which is, let's assume we always want to read data from the other end no matter what. We only want to know if we're writable in certain cases, which is 3, but we're only handling 2 right now. One is we're not connected yet, and we're waiting for the writable selection to know if it worked or not. 2, we have messages in our outbound queue that we need to write to the other side. And 3, we were trying to write something to the other side, but we didn't finish sending the whole message, so we have to send it again, which is distinct from there are messages to send, because one of them wants to know if the queue is greater than 0 in size, and the other one wants to know, what if there was only one thing in the queue and we only sent half of it? You obviously want to keep sending the rest of the message. You don't want to wait until the next one appears. So this is kinda what we want, except that this needs to know if not self-connected. We need to do something here to know. So the real question is, how do we pull that off? Let's look to see if it says anything. Oh, there's an X. Oh. Returns an error indicator instead of raising an exception for errors returned by C-level connect, such as host. Okay. So, we'll use this one. No, really? That's all that's going to say? Do. I was sort of expecting there to be some returns the remote address to which the socket is connected. On some systems, this function is not supported, and thus it is useless. Get sock op. Now that's what the man page said, right? That's how I would normally have done that. After select indicates writability, use get sock opt to read the error option at level sol socket to determine whether connect completed successfully. In this case, I'm assuming it in fact did not complete successfully because there's nothing listening. Let's copy this stuff here into here, like so, and return the value of the given socket option. The needed symbolic constants are defined in this module. If bufflen is absent, an integer option is assumed, and its integer value is returned by the function. Okay, so I think that's probably what we want for this. Code equals self dot socket dot get sock opt. Let's do this. Well, let's also do that. And this, just to shut it up. Okay. Selector poll, use getSockOpt to read the SO error at level sol socket. So the level is socket.sol socket, I would imagine. And the option name is probably socket.so error. We'll just print that for the time being. So what happens? Assuming we remove, well, push it back there. Get sock takes at least 2 arguments, 0 were given. Are you sure? Because it kind of looks like I stupidly stooped it up. Probably wanted that. I forgot halfway through what I was doing. Okay. It's returning 0. Okay. Was it always 0 or was it 1 at the top? One assumes that I could have changed that timeout. 111, I bet you that is connection refused. Okay. So, let's take it back up. Unsuccessfully. Okay, so the return, I can imagine the return value 0 is returned. Okay. Is there a way to turn? If code is equal to 0, self.connected equals true. Okay. So let's just quickly, I am pretty much at my hour of code for the night. And whoops, do need to Python erno to string. os.stir. Okay, well, I could have guessed that. I don't know what the Pythonic method of doing that is, but else we might say log connection failed .format os.stir code, and then we might say self.close to return ourselves, remove ourselves from here. Now we might also say connection established, and that just so that we can know that we actually have connected. Otherwise, you say connection failed and close, and maybe in is writable, we say if self.socket return that, return false, so that it doesn't try to be writable if it's not a valid socket. If that's the case, we might also need a def. No, we don't need to do that. We'll just do it down here. If c.socket is not none, let's say. So if a connection has a socket, it's selected for readability. If it's writable, select it for writability. And if the connection is in the right set, do that. So let's see what happens now. Connect with thread. Oh, let's let's go ahead and actually import that thing that I knew I was going to need to do. Yeah, exec.py bad file descriptor. That's sort of what I thought. Okay. Network thread has no connections to service. So see how well that actually worked. So it created the connection to port 50,000. The connection failed. The connection was refused. It gracefully closed the connection, and there were no connections to service after that. So it went away, which 100% what we want to see. And if we jump all the way to the bottom of this file, if we actually swap this to 7 to talk to the echo server, we can see that it's created in this connection and the connection has been established. And then gracefully closing the connection and it goes away. And that one worked because that's the echo server that I have turned on, so it said that it was connected. Now maybe we also want to throw in a 5 here. And we might say connected if self dot connected else empty string. Just so when we see it gracefully closing a connection there in that log, we'll see it say that it's connected. And when it's just gracefully closing the connection, socket is none, it also needs to remove that. Okay, that's socket equals none. We also want to say, I guess, connection dot connected equals false. Just so that doesn't happen. That's, that's one of those neither here nor there type operations. Okay. Now we are actually at an hour and 5 minutes, but just to verify that our idea, is a working. Here's what we can, maybe we can just very quickly throw in something and see if this is going to work for us. So if we come down here, we can say manager connect localhost 7, and we actually want to say the connection is equal to, yeah, we'll just say con is equal to that, right? And then we say con.send, and we want an introduction message. I believe that is how we were doing that. We can easily create a introduction message with no arguments and end up with something. Now let's just very quickly spin into what happens in the connection. If we send, we put protocol message instance. We're just going to temporarily say dot encode in here, like so. So what ends up in the send queue is bytes object. And this is receiving a message. Theoretically, it would actually be grabbing bytes. So let's say data equals self.recv q get no wait, like so. If data return protocol message dot from data return. Okay. No, we don't need to do that. This is either going to return something or it's going to throw an exception. The exception is going to make it return none. So We actually just need that. So now receive is actually going to be a message. And if we jump into is writable, if there's a socket not connected or send queue size is greater than 0. So if we're going to send, if we're not connected, then do this. And then we can say if data equals self dot send queue dot get no wait. That's the thing we just used up there, right? Yeah, to try to pull something. Oh, and we actually need to wrap that in this whole little pajigger here. Oops. Not that one. Is writable? No. Send. Here, we're going to do this. Try send queue, get no wait. Return queue empty. It can just, it can pass. Doesn't matter. But if we get here, we did get data, in which case what we want to call is sock.send, right? So self.socket.send, and we just need to pass the bytes there because the bytes object contains its own thing. So we might actually, well, we'll say data. We will actually say log transmitting %d bytes to the remote end dot format len data, actually transmit it. And here we actually get selected because we think there might be data. Now there may be, I'm going to guess this might throw exceptions like e would block. Try data equals self.socket.recv. And I believe that's what I was doing over here. I call it recv instead of receive because I'm a doof. We actually want to pass some size in. So yeah, we'll say 1024 bytes. And we might log received %d bytes from the remote end dot format len data, and then we can say self dot receive queue dot put protocol message from data except, and what was the thing that we were checking for there? Blocking IO error. Blocking IO error will let slide. Whoops, too far. That's actual receive. Oh, we actually just put the data in. We don't have to turn it into a message. That's going to happen here. All right, well, for now, that's okay. Maybe we would decide to change that later. If we're putting the data in there, we might expect this to come out with a message, but it is good enough for now, if you will. We actually want that. Let's see what that does. Ah, poop. Pardon my pooping. No, I did it in both places. Okay. 3 bytes, huh? Well, that's a pretty small message, I guess. Now it doesn't say that it's receiving messages, and that's probably because for con in our set, con dot receive, because it's kind of important. As a matter of fact, we might even underscore that because we really don't care about that at all for right now. It's kind of important to actually tell the things that were selected for readability that they can read. So there's it transmitting 3 bytes to the remote end. There's us receiving 3 bytes from the remote end. And that means if I was to come all the way down here, we send the introduction message, we time sleep, we say message is equal to con.receive. Thusly, if message, then we print, then we, well, log it, I guess. Received message from the remote end, and I don't think there's a nice thing, but we have to wait a second. A bytes-like object is required from struct.unpack. Oh, did I put the wrong stuff in the wrong place, didn't I? Let us double check what I did. When I receive, we're actually putting a protocol message in. Oh yeah, that's right. I'm going to say that that's how this should work. This should put a protocol message in here because it's going to receive data and it might not be a full message, so it might have to merge it. So it's actually going to put the message in, which means if I look at this one, this should go back to being what it was before, and it should just work. After a little bit of a delay. And I think we received a message from the remote end, an introduction message object at something something. Now, we're going to assume since we sent 3 bytes and we read 3 bytes, at the very least we know that the first byte was 0 because that worked, right? So for a more robust test, we would probably use error message, and let's use error code 77341926 just cuz, and this is an arbitrary error message. Go us. Spawner off, that's 52 bytes, and we received a message from the remote end. And it's an error message. Now we know it's an error message. So let's go ahead over to here, and we will know that an error message has both an error code and an error message type field in it. So we can copy that, which is actually something we could have done for the other one, but this is more exciting data. Let's do, whoops, that. Boy, I really boned that copy hardcore. I was expecting it to just go ahead and copy both the lines the cursor was on. So let's do that. We actually might even, we'll say, error received 0 and then 1, and we'll format it with message.error code and message.error message. Get rid of those. And one last spin around the block, and that sleep probably doesn't need to be quite as long as it was, but it says it received an error message 77341926. This is an arbitrary error message. Go us. We have successfully transmitted a message to the other side and received it. So we're going to call that a bully for success. Now, this send code needs to be a hell of a lot smarter because we can't assume that our send sent all the data. And in fact, send returns the number of bytes that it's sent, which might be none. And it may also, it's probably possible for send to return ewood block. Just in the general case, in theory, that should never be something that happens because we only call in when we're selected as writable. But as I've mentioned before, socket code can kick you in the butt because sometimes the way the TCP protocol works behind the scenes in one of those, seven layer dip models, if you're familiar with the 7 layers of the OSI, somewhere along in there, it's possible for a data transfer to happen in a way where you think there's more data than there is, or there is less data than you thought there was. That's another way of saying the same thing, isn't it? You might a good example of this that I have definitely seen far too many times is you make a socket that's a listen socket. And when a listen socket selects for readability, that means that there's a new connection to accept. And you would expect in that case that the kernel knows that it has a pending connection. And it does. But in between the time when the select happens and you actually try to call accept to read the connection, there can be more TCP traffic behind the scenes that says, oh, that packet was delivered in error. And it goes away, and now your accept call just hangs forever if it's not non-blocking. It's very weird, but I have seen it happen on more than one occasion. And it made us really unhappy at work because we were in the middle of trying to port everything to Solaris, which might explain why that happened. But in any case, we are at an hour and 20 minutes. I have gone a little long here for the purposes of being able to pull a blog off of cameras and recording it, but we actually have done a fair amount of work here, and I'm pretty pleased with our progress. So we're going to go ahead and call the stream here and get the devlog ready, and I'll do all of the stuff necessary to make these changes commit and get pushed up. And tomorrow we will work on making our send and receive code smarter, which basically is capture how many bytes that you sent and then send the remaining ones. We also have to send the payload size, which we're not doing right now because this is a very crude test. And when we receive, we need to make sure we first get 4 bytes that are the size, and then once we get those 4 bytes that are the size, then we can proceed to read the payload, and only when we get all of it do we know that we have enough data for the message instead of just assuming that the read call returned everything we need. And in order to verify that our code works that way for incremental sends, since I'm assuming we're probably going to get as much data as we send back because it's talking to localhost, we can modify our send so that no matter how many bytes it thinks it needs to send, it always just sends everything 1 byte at a time, which is slow, but it'll totally allow us to know that the reception end is smart enough to read partial reads, which is most important on those 4 length bytes the same way, which is going to be a lot easier on the transmission end. So let's call that. Thank you so much for watching the stream and coming along on the networking journey, and have a sublime day. ODAT Nerd signing off. I'm saluting, but you can't tell because I don't have a camera. I'll salute in the vlog.